Hello everyone. In this video, we will be discussing about epicyclic gear train. In an epicyclic gear train, the axis of the shafts over which the gears are mounted. You can able to see this. This is the axis of the shaft over which the gears I have two gears I have taken, that is gear A and gear B, which is mounted, may move relative to their fixed axis. I will explain you what is the concept of this one. I'll be naming the first gear as A and the second gear as B and the arm as C. Now we can able to see this. Gear A and arm C have a common axis. So this is the axis of the gear and this is the axis of the shaft, that is the arm. So which is having a common point. So that point is nothing but O1, about which they are rotating. Similarly, gear B, this is gear B, it is meshes with gear A. Gear B, it is meshes with gear A and has its axis on the arm at O2, about which this gear B can rotate. So, the detailed explanation is here. If arm is fixed, that is this C, if this arm is fixed means the gear train is simple kind of gear train, because gear A is the driver and gear B will be the follower, and gear A can drive gear B or vice versa. If gear A is fixed, say for example, if gear A is fixed means the arm is rotated about the axis of the gear, that is on O1. Then the gear B is forced to rotate upon and ground and around gear A. Such a motion is called as epicyclic. So this particular sentence is very important. If gear A is fixed, then arm is rotated about the axis of gear A, that is O1. Then gear B is forced to rotate it upon and around gear A. Such a motion we are calling it as epicyclic. The gear trains arranged is in such a manner that one or more of their members move upon and around another member are known as epicyclic gear trains. The epicyclic gear trains may be simple or compound. Both cases will be there. The epicyclic gear trains are useful for transmitting high velocity ratios with gears of moderate size in a comparatively lesser spaces. This is very important. The applications where and all these cases are there, we can go with the epicyclic gear trains. The epicyclic gear trains are used in the back gear of lathe, differential gears of the automobiles, hoists, pulley blocks, wristwatches, etc. Now, this is a very important concept, that is the velocity ratio of epicyclic gear trains. We can find out by using a tabular method and algebraic method. So, any one method we can go. Usually in examination, we will be following the tabular method. So, now I will be explaining how to follow the epicyclic gear train velocity, how to write the velocity epicyclic gear train velocity ratio in tabular method. So, first, let me consider the same example for all the epicyclic gear trains tabular method, so that it will be easy for me to remember. Consider an epicyclic gear train, the same epicyclic, that is gear A, gear B and arm C. Let TA is the number of teeth on gear A and TB is the number of teeth on the gear B. Now, first tabular method means this is the common things I need to always keep. So, always I need to put the first as the arm. In the first column, I need to write the arm, and second one will be the arm which is connected with the which gear first. You can able to see this arm is first it is connected with the gear A and the next one is the gear B. There are cases where after arm the first gear, second gear, third gear, fourth gear, fifth gear also will be there. Such kind of cases also we will be going with first arm, then first gear, second gear, third gear, fourth gear will be going. So since here two gears and one arm is there, first I will be going with the first column as arm and second one is the very first gear and third one is the second gear. So what is the first row? In the first row what I will be writing means, let me consider the arm is fixed. So most of the conditions arm will be considered as the fixed one. So if the arm is fixed means we know like the A rotates through +1 revolutions. So I will be considering the anti-clockwise direction as the +1. If the A is rotating in the anti-clockwise direction means obviously the B will rotate in what? The opposite directions. So, so for the gear 1, since the +1 revolution have given, if the A is, if arm is fixed means A will rotate. Say for example, first one rotation, I'll be going with +1 rotation in the anti-clockwise directions. So if this is rotating in anti-clockwise direction means B will rotate in what? Clockwise directions. So the ratio will be TA by TB. This negative sign indicates it is rotating in the opposite direction of the gear A. Now moving to the second row, again same condition, arm is fixed, gear A is rotating. Previously it was first one rotation, now I will be going with the plus X rotation. Plus X means it can be 2 revolutions, 3 revolutions or 4 revolutions. So let me multiply that many revolutions in the gear to the gear B. So minus indicates it is rotating the opposite direction. So minus X into TA by TB. Now the third, add plus y revolutions to all the elements. Now the very first step it was +1 revolution of gear A, and second step will be I'll be adding plus X revolutions, and third one is nothing but plus Y revolutions everywhere. It is not one like only A and B, now even including the arm. So now if everything is rotating means I'll be adding up plus Y plus Y plus Y in everything. So the total motion will be there for this case 0, 0, 0. So plus y. So x plus y, and here will be y minus x plus TA by TB. So here you can able to see. So the first condition is R is fixed one. So I will be rotating gear A usually in the anti-clockwise direction. So the positive. So only one revolution I will be giving. So +1 in the gear A. Since arm C is fixed, so it is 0. There is no revolutions. So the gear B rotation with respect to the velocity ratio, it is TA by TB. So since gear A is rotating in positive direction, gear B is rotating in the negative direction. So minus. So the next condition, again the arm is a fixed condition only. Let me assume that gear A is rotating in the plus X revolutions. So I'll be adding gear A plus X. Since arm is fixed, so it is 0 only. So gear B will be multiplication of X. So minus X into TA by TB. Next step is add plus Y revolution to all elements. Now I am not considering the arm C is fixed. Now everything is free to rotate. So I'll be adding a plus Y revolutions to A, B and C. So plus Y plus Y plus Y. So the total motion will be, now add these things. So plus Y. Now it is plus 1 plus X plus Y. So it is overall it is X plus Y. Now it is minus, so Y minus X into TA by TB. So this is the basic table we need to remember for solving any epicyclic gear train problem. The condition may vary. What is the condition means? There sometimes they may say that gear A is fixed or gear B is fixed or gear C is fixed. Like that the conditions will vary. But for all the cases, if you follow the same method, that is first one is the arm, second one is the first gear, then second gear, third gear, fourth gear. Then the first condition will be step 1, step 2, step 3, step 4 will be, first step will be always first giving plus revolutions to the first A, and the second revolutions with the X revolutions, and adding everywhere, that is A, B, Y everywhere, and last one is nothing but writing out the formulas. We'll discuss a problem so that we can understand still in a better way.